Is it worksheet 3 yet or no?
Before we get started, eventually we will, today's lesson is a subset of differential equations. So we've done differential equations. Now we're going to look at a specific type of differential equations. But before we get to that specific type, let's remind ourselves how we do differential equations. We separate, then we integrate, and then we solve for C, which we made up the word quantitate, which, just to make it rhyme, but really that means solve for C. So I hope that part sounds familiar. Separate, integrate, solve for C. That we've done before. That we'll do today with a specific type of question. So today is a review of the differential equation stuff, because it's just a specific type of them. Okay. In this section, we'll create and solve differential equations. So solve we've already done. Create, that'll be new today, is the creating part. And the creating part is really the easier part. And there are a couple questions on the test that are just create, and you don't even solve. So that's kind of nice. All you got to do is set it up right. Create and solve differential equations which describe the rate of growth or decay of a function in a situation. Okay, let's remind ourselves of proportionality and some vocabulary stuff. The statement, y is proportional to x. Do you remember what that means in terms of an equation? Y equals... But it doesn't just mean y equals x. That is proportional to... means there's a k there. So as x goes up, y goes up, but there's some extra factor in there, k. M is proportional to the square root of w. So m equals thank you, proportional to, so that's k. How about the square root of w? I don't even know how to ask that. It's the square root of w. So is proportional to means stick a k in there. Right? The rate of p with respect to t. Do we know what that translates to? Rate of p with respect to t. It's a derivative. dp dt. That's the rate of p with respect to t. Is proportional to, so equals k times p. Again, there's, I think, 2 questions on the test that they're like the first 5. It's just not solving, just setting it up, just writing. In the above equation, how would you solve for p? Well, separate, integrate, quantitate. So that would be dp over p equals k times dt. There's our separate. And then we would integrate, and then we'd solve. You know what? Let's go ahead and do this one, because it's been a while. Not much space there. What's the antiderivative of dp over p? Natural log of p. And what's the integral of k dt? Okay, careful. It's not k squared over 2. It would be that if this was dk. So since the k is not the t, like those are different variables, the k can just slide out. What's the antiderivative of 1 dt? Let's see. put the k out front. What's the antiderivative of 1? T. So this would be kt plus c. And then what would we do to solve for p? Base e in the loop-de-loop thing, the fishhook thing. So this would be e to the kt plus c equals p. And then there's one more algebra step that we usually take. You can put that c out front. It's a different c, but since we don't know what it is yet. Most of the growth and decay equations are like this, and therefore most of the differential equations on the test are like this. Like that exact set of steps. And then you might have different variables in there. Obviously you have different C's and K's and different information, but a lot of them start with that. And you end up with that as your answer. And in fact, some people, after we've done enough of these, they just skip all the steps and like, oh, I know what that is. That's the equation that leads to that. We're probably not there yet, but we're going to do enough of them where I hope some of you get to that point where you see this, and you're like, oh yeah, I know what that's going to be. Move things around, integrate, do the algebra trick, and land there. We can apply this to many growth and decay situations where the rate of growth of the material is proportional to how much of the stuff there is. Again, 1 through 5, this is like supposed to be the easy stuff. There are, I think, 2, maybe 3 test questions just like this. Water evaporates from a puddle at a rate proportional to... Okay, lots of words in here. Let's just read it through and then we'll back up and translate. Water evaporates from a puddle at a rate proportional to the square root of the amount of water present. Write a differential equation describing the rate of change. Okay. So the rate means we'll have a derivative. Let's see, water. So let's use dw dt. That's our water evaporating rate, dw dt. How much water is changing per time. Proportional to, so k times the square root of the amount of water present. So the square root of what then? Well, we got 2 options here. W, because W is how much water there is. Now, I think we should probably make one slight adjustment to that problem. Probably shouldn't be problem 1 because of the adjustment that we need to make. You know what? No, we don't need to make it. Never mind. Leave it alone. We're good. Number 2. The number of giraffes in a large preserve increases at a rate. Okay, rate means derivative. So, let's see. How about dg dt? Proportional to. There's our k. The 10th root of the population. So g to the 1/10. Or I suppose we could have written it like that. That would look more like the 10th root, I guess. G, not 6. Why don't you try 3, 4, and 5? Again, I'm hoping these are easy. That would be fine as well. So I feel like those are pretty straightforward. You look forward to seeing those on the test, I hope. Just don't even solve them, just set them up. The test is all multiple choice, so you could guess what the wrong answers would be. Probably have dB dt equals k times b on that one. That would be a wrong answer. Maybe leave out the k, just put t over there. That wouldn't be right. So between the ease of the problem and the multiple choice, I think those should be good ones for you. Okay, number 6. Now we get to actually work a problem here. Population of frogs increases at a rate proportional to the cube root of the population. Okay, that's exactly the same statement that we just did. So dp dt equals k times cube root of p. Addie, your question from earlier, like we probably should be good math students and say that p equals the population of frogs, like labeling our variables. But in a short problem, when there's only a couple things going on, it's really not that big a deal. Okay, if the population of frogs changes from 27 frogs to 216 frogs in 1 year, what is the population of frogs at the end of 5 years? Okay, that's a lot of information, and I like to put all that information in a table because then I have a set of ordered pairs that I can use. So I think this is saying at time 0, like when we start our experiment, there's 27 frogs. And after 1 year, there's 216 frogs. And by the way, both of those are perfect cubes, so I think this is going to set up to give us nice numbers in the end. What is the population of frogs at the end of 5 years? All right. A lot is going to be my guess. So we've got a differential equation. So let's separate, integrate, solve for c. So dp over cube root of p equals k dt. Except I don't really like cube roots when I want to integrate. So Autumn, what would be another way to write the cube root of p in the bottom?
P to the 1/3.
Yes, depending on how I phrase that question. If I don't want it in the bottom anymore, if I want it in the top,
P to the -1/3.
yeah, p to the negative 1/3. So p to the negative 1/3 dp equals k dt. All right, now we're ready to integrate. That's our separate step. We'll integrate. So, Justin, how about the left-hand side? What's the antiderivative of p to the negative 1/3?
3/2 p to the 2/3.
Yes. Increase the power by 1, divide by the new power. Good. Ava, how about the other side? What's the antiderivative of k dt?
KT plus C.
Good, kt plus c. Okay, oh, I've got two unknowns in there. I've got k and c that I've got to figure out. Do you think that's going to be a problem or not based on the information that we have? Why is that going to be okay that there's two unknowns? They gave me 2 points. So hopefully 1 point will lead to k and the other point will lead to c. And so this actually fits well with separate, integrate. We did both of those. And now when we say quantitate, we got k and c to figure out. So that little method works even for multiple variables thrown in here. Separate, integrate, quantitate. I gotta find K and C. I think I need to solve for P though, so let's get P by itself. Let's see. So when I multiply by 2/3, this is one of those tricky things here. I haven't figured out what K and C are yet. So what's 2/3 times K times T? KT. And what's 2/3 of C? C. Now that's a little bit misleading because this K is now not the same as this K, and this C is not the same as this C, but it doesn't really matter because we haven't figured out what they are yet. Again, if that bugs you, then label them something else or put a subscript on them. Okay, that means that P is equal to KT plus C to the 3/2. Okay, well, I got two unknowns, K and C, and 2 points, so this should work out. Which point do you think we should use first? Which do you think would be most helpful? Yeah, use the 0. Hopefully that wipes some things out. So 27 is the population. T is 0, so yeah, that'll wipe out that part of the problem. So I think I'll be able to figure out what C is. So 27 equals C to the 3/2. Let's do 2/3 on both sides. Jameson, you remember your power rules well enough to figure out what 27 to the 2/3 is? The root's on the bottom, the power's on the top. So the cube root of 27. And then 3 squared? 9. So C is 9. Okay, so we found what C is, so I can kind of start over here. So P equals KT plus 9 to the 3/2. Now let's use the other piece, or the other point. 216 frogs at time 1. So 216 to the 2/3 equals K plus 9. You will have a calculator on part of the test, so on one like this you'd probably have a calculator. But do you know what the cube root of 216 is? 6. And then 6 squared is 36. So K equals 27. So P equals 27T plus 9 all to the 3/2. So there's my, not the answer that it's looking for, but there's the equation where I've solved for everything. And now I just want to plug 5 in. So 27 times 5 plus 9 to the 3/2. And I guess we could just safe stop that and call it a day. Unless you had a calculator, because I don't know what that number would be. Not very nice. 27 times 5 plus 9. So it's 144 to the 3/2. Square root of 144 is 12, and 12 cubed. I don't know what 12 cubed is. Yeah, safe stops are great, but on word problems, sometimes it's nice to get the answer to see if it makes sense. Like we knew there was going to be a whole bunch of frogs, so that I feel like sort of makes sense, right? If you got negative frogs, that would be bad. If you got decimal frogs, that'd be bad. If you had 8 billion frogs, it's like I don't think it grew that much. So I think it's worthwhile to get the answer on these word problems because you get a feel for if it's right or not. Number 7. Bacteria culture starts with 500 bacteria. McKenna, what's that telling me?
That's 0 is 500.
Good. So that's good. That's 0, 500. They just gave me a point. The starts means times 0. And grows at a rate proportional to its size. Ben, can you write me a formula that says it grows at a rate proportional to its size?
dV over dt
Uh-huh.
equals Ks.
Let's say KB, because B is how much there is, so I don't want to introduce extra variables here. So if B is how many bacteria there are, B is the number of bacteria, then yes, dB dt equals KB. After 3 hours, Jimmy, there are 8,000 bacteria. What does that mean?
3, in the body.
Yeah, so there's another point, 3, 8,000. So you can write them as points, that's fine. If you want to write them as kind of a set of points, as ordered pairs in a table, maybe that's helpful to kind of organize the information. Not necessary, but maybe it's helpful. Okay, part A. Find an expression for the number of bacteria after T hours. So that means I need B equals something with T in it. So let's separate dB over B equals K dt. And now we'll integrate both sides. Good. Natural log of B. Again, this is going to be the most common type integration on the test because it's the most common type of growth and decay. So natural log of B. Johnny, how about the other side?
KT
You want to include anything else on that answer, Johnny?
plus C.
Plus C. Okay, my goal is to get B by itself. So, Caden, what should I do next?
Put E on both sides, so there's E to the KT plus C.
So B equals E to the KT plus C. I like that. It's not wrong, but there's one more thing we could do, Andrea, to clean that up a little bit.
We can do the C.
Yeah, we could make that B equals C E to the KT. And another one where there's two things that how about that for an equation? Just step back for a minute. We're now doing math where there's 5 different letters in there. E is a constant throughout history, like that's the 2.71. B and T are the variables in this equation. C and K are the constants in this equation. Jace, what should I do next? How's that for an open-ended question? What should I do next? My goal is I need to figure out what C and K are, so what would help me do that?
Plug in.
Plug in what? Which one?
For B.
What do you want to plug in for B?
Like 500 and 0.
Yeah, let's do that one first, because the 0 in there will make life a little bit easier. So 500 equals C, we don't know. E, that's just the number in the calculator. K, we don't know. And T is 0. Well, I'd say that's a great choice, Kenneth? Because what does C equal?
Zero.
Well, let's back up. What's e to the 0?
1.
1. So what does C equal? 500. So we like it when they give us a 0 point because that makes life really easy. So C is 500. Okay, so B is 500 e to the KT. James, what do you want to do next? Plug in again at the other point. So 8,000 in for B. Don't know K. T is 3. I think we're going to need a calculator for this one. For All-Star. What do you want to do to start to get K, or to continue to get K by itself, I guess I should say? How do I get that 3K out of the exponent? What? One? Yes, natural log. Let's natural log both sides. Because that allows the 3K to come down front. And we get natural log of E. And Kelsey, what's the natural log of E? It's just 1. Natural log of E is 1. So 3K equals natural log of 16. So K equals natural log of 16 over 3. And I think I just want to leave that like as a safe stop. I could put it in my calculator later. So B is 500 e to the KT. And I've told you what K is, so I don't need to rewrite it. I don't really want to get a decimal for it. It's okay to write this as your answer as long as you said what K is. So that's probably the easiest way to go. Now, we might need to know what K is in a little bit, so I'm going to find natural log of 16 divided by 3. And I'm going to store it in my calculator as K. So store as K. And then now, when I need it, I can just press K. I don't have to type in natural log 16 over 3 or type in 0.92419624007 over and over again. How many bacteria are present at the 4-hour mark? So, Aslan, what am I going to do to answer that question? Set T is 4.
What's the answer to the last question?
So the answer to that last question was this formula, because it wanted an expression, not like a number answer. So the answer was that expression, 500 e to the KT.
Oh, why did you solve it?
Well, because it wasn't finished until I told you what K is.
Oh, okay.
Yeah. You also could have boxed up C e to the KT as long as you told me what C and K are. But C was an easy one, so we filled that one in. Okay, so when T equals 4, well, let's plug in T equals 4. So 500 e to the K times 4. And my calculator knows what K is now, since I told it. And the calculator has always known what E is. So 500 times E to the 4K. So 20,158. And it didn't say round to the nearest one, so I guess we should round to 3, even though you can't have 0.737 bacteria. Again, AP test is almost always 3 decimal places, But on these population type problems, it will usually say something like to the nearest person or to the nearest bacteria, because 0.7 bacteria, that doesn't really make sense. All right, part C, when will the bacteria reach 30,000? So what do I do for that one? Plug what in where? Okay, well the bacteria is 30,000, so that's my B. 30,000 is the bacteria. And then I've got to figure out what T is. So more algebra for us. Algebra all-stars all over the place left here. So, Holly, all-star algebra number 1, what should we do first to start to get T by itself? Divide by 500. So maybe I should be able to do that in my head, but maybe I don't want to make a mistake. So 30,000 divided by 500 is 60. So 60 equals e to the kt. Avery, what do you want to do next in our sort of pursuit of T? What's that? Natural log both sides. And I keep writing K, but be careful. We know what K is. It's not a variable anymore. It's not an unknown. Like, I know what K is. I just don't want to write 0.924 every time. Seth, why did Avery natural log both sides?
Because natural log is 1, I can bring KT.
Okay, so KT can come to the front. Natural log of E is 1. And I'm out of popsicle sticks. But that's okay, because the only thing left to do is what? Divide by K. Right? My calculator knows what K is, so natural log of 60 divided by K, 4.430. And we're in hours. Didn't really have room, but if I'd have kept up with all of our data points here, we found when it was 30,000, that was at, that was at 4 hours, or 4.4 hours. At 4 hours, it was 20,158. So I like, if I list them all in order, that kind of makes sense. Like, nothing's out of order there. We're increasing as we go. So just putting all the data in one spot kind of helps me keep track of if I've made any crazy mistakes in there. All right, that was a whole lot of algebra and a little bit of calculus. I didn't do this intentionally, but looking back, that one thing in red, there's the only calculus in the whole problem. Was that integrate step. After that, it was all algebra. We'll save those next two for tomorrow to look at. So today, I would say try worksheet 3, 1 through 8, but not 3 and 4, because those match up with the last two examples. Again, test is Thursday. Make sure you've got your College Board login stuff.